Welcome back everyone. In this lesson we are going to begin to create our player controller and we are going to be setting up the player inputs. These are going to be the buttons that the player is going to press in order to do certain things. So to begin, let's go to our project settings window here. You can open this by going edit and then project settings and it will open up like so. And in here we just want to go down to the input tab and we can create our action mappings and our axis mappings. Now, an action mapping is a single key press, so if you want to jump, we press space. If you want to shoot, we press the left mouse button. Those are actions. Whereas axis mappings are basically a range between two keys, which correlates to a scale. So if we want to move forward and back, that is going to be one axis mapping. For example, when we press W, the axis is going to be +1, whereas when we press S, the axis is going to be -1. So then we can use that in order to figure out, okay, which direction do we move, forwards or back. So let's start with our action mappings over here. What I'm going to do is I'm going to click on the plus here. We can click the drop down arrow and this first action mapping is going to be called shoot. We then want to choose which key shoot is going to be. So this we can just search for left mouse button. It can be whatever you want. And then we also want to create another action mapping. This one is going to be called jump. And this is going to be set to, if we just search for spacebar, there we go. Now for the axis mappings. So we can create a new axis mapping here and you'll see that we can give it a name. I'm just going to call this one move_forward back and we can choose a key. And you'll see that there is also this scale next to it, which we can modify as well. So first of all, let's set up a key. I'm going to set the first key to be W, so we can find W here. I'm going to then add another axis mapping to the group here by clicking on the plus near the move forward back axis mapping. And this one is going to be S. Okay, we can find the S key here. So let's move over to the right hand side where we have the scale. And what we're going to do is we're going to set the W scale to 1 and the S scale to -1. And this basically means when we're moving along the our x-axis, because remember the x-axis is forward, so our player, whichever way they're looking, we're going to be moving towards their local x-axis. When they press W, that's moving forward, so we're going to be adding to that, whereas if they press S, they're moving backwards, so we're going to be subtracting from that. Okay, we can then do the same by creating another axis mapping, and this one is going to be called move_left right. We can then add in the left key, which is going to be A. We can find the A key here in the list, and we can then create the D key as well, which is going to be in order for us to move right. Now in terms of scale, A, since A is moving left, that is moving into the negative, so we're going to make A -1 on a scale, and D 1 because we're moving positively along our local y-axis. So that may be a bit confusing to you perhaps, but once we actually start setting this up, connecting it to our player and moving around, it will make much more sense. So that is all the inputs set up for our player. If you want to create more things for the player to do, you can of course add many more inputs here, as many as you wish. But for right now, we're going to go back to the main level and we're going to go to our blueprints folder. And what we're going to do here is we are going to be creating a new blueprint for our player. So I'm going to right click, I'm going to go blueprint class, and we're going to be choosing the blueprint parent of character. Now what character does is basically similar to a pawn, but it does include various other things that we can use, such as nodes, and it includes some base components that we can just drag and drop our stuff into. So I'm going to select character here, and I'm going to call this one our player. We can double click to open it up inside the blueprint editor right here. And as you can see straight away, there are a few things already made for us. We have our capsule component, which is going to be our collider. We have an arrow component, which basically tells us which direction is forward. We have a mesh component, which is going to be what our player looks like. Now, we're not going to be using the mesh component because this is a first-person game, so we're not going to be having a character mesh. And then we have a character movement component down here, which gives us a large number of different properties for us to modify for our player. Our movement, our walking, our jumping, our falling, our swimming, our flying, basically everything you want to do in order to fine-tune this player, you can do here in this details panel here, selecting the character movement. So first of all, what we need to do is set up our character. And the first thing we will probably need to do is actually create a camera for us to look through, because right now we don't actually have any way to look through our player's eyes. So I'm going to add component, I'm going to look for camera here, create that. You can see the camera right there as that blue 3D model, and the center point here, the center axis, is where the camera is going to be looking out from. Now we want to set the camera position to 0, 0, and 90 on the Z, so the camera is just sitting on top of the collider like so. So now with the camera, we need to set up the actual gun model as a child, so we can look through the gun, we can see our gun model there, and the way we're going to do that is by just adding a component to the gun here, and this is going to be a skeletal mesh. Now, you may think, what's the difference between a skeletal mesh and a static mesh? Well, a static mesh is basically a 3D model that doesn't do anything, pretty much. Well, whereas a skeletal mesh is a 3D model that has a skeleton, such as a character, which can move around based on animations. Now, this gun isn't going to be moving around or anything. It doesn't really have a skeleton that we're going to be modifying, but that's just the way that the 3D model has been set up by Unreal, so we have to use a skeletal mesh for that. I'm going to also rename this component to gun model, and down here where it says skeletal mesh, we can click none and choose our sk_fp gun. And there you go, you can see it in the scene here. It has some pretty good material, so it's nice and shiny. It's got a sort of matte finish on the barrel there. Now let's position it in place where we want it. So first of all, the location, we're going to set to 40 on the X, we're going to set 20 on the Y, and -30 on the Z. And for the rotation, we just want to set it -90 on the Z, so it is facing outwards like so. Okay, so we got that all set up. Now what we need to do is create a component which is going to basically tell our gun where the muzzle is, because when we spawn in a bullet, we need to know where we are spawning the bullet, and the way we're going to do that is by, as a child of gun model here, I'm going to add component, I'm going to create a static mesh right here, and I'm going to call this one our muzzle. Now, we aren't going to actually be attaching a model to this, we're just going to be using this as a point in 3D space to signify where our muzzle is, so when we spawn a bullet, we can just spawn it at this muzzle component's position. Okay, so I'm going to set the location here to be 60 on the Y and 10 on the Z, and there you go, it is positioned where we want it like so, but we want the forward direction to be facing forwards from the gun, because if you remember, the X-axis in Unreal is generally classified as the forward direction, and that is represented by the red axis right here. So what we want to do is rotate it so we have this red axis facing outwards from the gun. So to do that, I'm just going to set the Z rotation here to 90. That is our components pretty much set up and ready to go on our character right here. What we can do is we can save, we can hit compile, we can return to the main level here. And for the player to actually spawn into the world, we'll need to create a game mode blueprint, which basically defines what the default player is going to be. So we can right click, blueprint class, I'm going to choose GameMode Base, we can rename this to MyGameMode, hit enter, double click to open it up, and all we want to do in here is go to the details panel and change where it says default pawn class to be our player. And there we go, that's all we have to do. So we can hit save, we can hit compile, we can close this blueprint down, and back in our main level, in the details panel here, you'll see that there is a tab that says world settings. Click that, and down where it says game mode override, we just want to set that to be my game mode. So now for this level here, it's going to know, okay, the default player that we want to spawn in is going to be this player blueprint right here. So we can press play, and you should see that here we go, we have our player in the game, we have the gun model on screen, and everything is set up and ready to go. So in the next lesson, what we're going to be doing is starting with our blueprint scripting. We're going to be creating the logic to look around and move around. So I'll see you all then. Welcome back everyone. In the previous lesson, we set up our player blueprint right here. We set up all the components, and now we are ready to actually start visual scripting. So inside of our player blueprint here, let's go over to the event graph tab up here, and this is where we have our nodes that we can connect. So first of all, we're going to be setting up the movement. We're going to be moving forward and backwards, as well as left and right. So since we don't need any of these nodes here, I'm just going to select all of them and delete those right there. And to begin, we're going to create some event nodes which are going to be called whenever we press our corresponding inputs that we created in the project settings tab here. So I'm going to right click and I'm going to look for move underscore forward back, the axis events right here. And this here gets called when we press either the W or the S key and the axis value carries over the scale. So what we're going to do here is we're just going to drag out from this and go add movement input. Now this node does all the movement pretty much for us. It takes in a world direction and a scale value, and it'll automatically move us along that. So axis value, we can plug straight into scale value here, and the world direction is going to be our forward vector. So we can just go get actor forward vector, like so. It's going to get the actor's forward direction, the local forward direction, and move along that. So that is how we can move forwards and back. If we compile, save, and press play here, you'll see that we can actually use our W and S keys to move forwards and back. Oh, fell off the platform there, but you get the point. Now, what we can also do is add in the ability to move left and right. It's pretty much the exact same thing as we just done there. So I'm going to look for the move underscore left right axis event right here. We're going to plug that into an add movement input node. This add input movement node is going to have a scale value of our axis value, and the only difference is that the world direction is going to be equal to get actor right vector instead. Alright, there we go. Now again, we can press play and you'll see that we can use WASD to move in all four directions. Okay, so we got that set up, we got the movement set up. In fact, I'm going to select all of these, I'm going to right click and I'm going to go create comment from selection, and I'm going to call this movement. What this basically does is it gets all of the nodes we selected and puts in this little container or comment so that it is self-contained, and at a glance we can instantly see what these nodes are doing. Okay, so I'm just rearrange it like so. And now what we can do is actually get working on the mouse look. So we can use our mouse to look left, right, up, and down. So what we're going to do for that is get the event tick node. So we'll go event tick, and event tick, this node gets called every single frame. So if your game is running at 60 frames a second, this will be called 60 times a second. And what we want to do here is basically add to the controls yaw and pitch based on the mouse movement. So for this, I'm just going to drag out from event tick and I'm going to go add controller yaw input like so. And with this here, you can see we have target. We can just keep as self because we are the target we want to add the yaw to. And for the value here, we want to get our mouse X. So I'm going to right click, go get mouse X. This is going to get the X movement of our mouse, so the left and right movement of our mouse. And we can plug that into value right there. Now if we press play, you'll see that when we move left and right, we can look left and right. So there we go, we got that set up. Now what we need to do is basically add in the vertical look. So from add controller yaw input, we can drag off from that and go add controller pitch input, which is vertical. And the value for this is going to be get mouse Y. Get mouse Y, like so. And if we press play, you'll see that we can't actually look up and down. And the reason why is because it isn't actually moving the camera, it's moving the actual player body itself. And that doesn't really work that well when you think about it. So what we need to do is select our camera here in the components list, and we want to enable use pawn control rotation. Now what this means is that when we're rotating based on these add controller inputs, it is basically going to be rotating the camera as well. So we can save that, press play, and you'll see that we can look up and down. But something you may notice is that the vertical look is inverted. When we pull the mouse down, we look up, and when we push it up, we look down. Now you may be used to this, some people are used to a inverted mouse on the y-axis, but for us what we can do in order to invert the invert is by multiplying this value by -1. So we're just going to delete this connection here, drag off from get mouse y, put that into a multiply by float node, and multiply that by -1. There we go. We can then plug that back into value here, and if we press play, you'll see that the mouse input is now corrected. We can also move around, and you'll see that we also move relative to wherever we're looking. If we look forward in this direction, press W, you'll see we move forward. Any direction we look, we move forward in that relative direction. And just like before, I'm going to select all of these nodes, right click, create comment from selection, and I'm going to call this one our mouse look. There we go. We can reposition the nodes like so. And now what we want to do is set up the ability to jump. And since we're using the character movement component right here, it comes with a lot of handy nodes for us to use, such as these add movement input and add controller your input nodes. And the same for jumping too. So what we're going to do for that is basically get the input action for jumping. So we can go jump, you'll see action events jump, we'll get that. Now on this jump event, there are two execution paths. We have pressed and released. Pressed gets triggered once we press down the key, and release gets triggered once we release the key. Now we want to jump straight away, so we're going to go out from pressed, and we're going to put this into a branch because we don't want to be able to jump if we are in the air. We only want to jump if we are standing on the ground, so that condition is going to be right here. And to get that, we can just right click and go is moving on ground. There we go, and this node here basically returns true or false for whether or not we are standing on the ground. We can plug that into the condition like so, and if that is true, so if we are standing on the ground, then we can just call the jump node right here. And this is just going to jump us up in the air. So there you go. As you can see, using this character blueprint comes with a lot of handy nodes that we can use to easily implement a character movement. Because as you can see right here, we have movement, mouse look, and jumping all in just these nodes right here. So if we press play, you can see we can look around, move, and of course with the space bar, we can jump in the air. Now you can of course modify these values because as you can see, when you jump, you actually have no control in the air. You may want that for your game, but for us, we probably want to give the player a bit more in-air control. So I'm going to select character movement, and we're going to modify a few things. First of all, we're going to change the max walk speed from 600 to 700, so we move a bit faster. And down here where we have character movement jumping / falling, we are going to be changing the jump Z velocity up to 600, so we have a bit of a higher jump. And we're going to change the air control here to be 1, so we have total air control. Now air control ranges from 0 to 1, 0 meaning the player has no control over where they go in the air, and 1 meaning they have total control. So we can save that, press play, and you can see we move a bit faster, we can jump a bit higher, and we can also move while we are in the air, which is good. You may of course not want this, and of course there are a lot of properties here for you to modify, to tweak, to experiment with, to basically get the fine-tuned character controller that you want. So finally, I'm just going to put this jumping here into a new comment called jumping. I'm going to reposition it like so, reposition these nodes, and there we go. This is our character movement basically set up and ready to go. We've got movement, mouse look, and jumping. In the next lesson, we're going to be setting up the ability for us to actually start shooting, so we can shoot bullets, and we'll also set up that bullet blueprint as well, so then later on it can detect if it's hitting an enemy. So yeah, thank you for watching, and I'll see you all in the next lesson.